So as we move into imaginary numbers, this question here says, write the power of I as I, -1, -I, or 1. So one thing to pick up on in math is there are some patterns that we can pick up on here. And, I is I, but by definition, I squared represents a -1. I cubed really is the same thing as I squared times I. Well, we know that I squared is -1, and -1 times I is the same thing as -I. And if I do I to the fourth is going to give me I squared times I squared. Well, that's -1 times -1, which is going to end up being a +1. If I go I to the fifth, notice that I to the fifth, notice how I have all this up here to use. I can actually use this I to the fourth. So if I go I to the fourth, whoops, that don't look very neat. I can write this as I to the fourth times I. Well, we know I to the fourth represents 1. 1 times I is I. So if I continue on, I to the sixth, notice how that's really the same thing as I to the fifth times I. Well, that's going to just be I times I, which is I squared, which is -1. So notice how if you raise I to different powers, you're either going to get I, -1, -I, or 1. So we have, in this situation, I to the fifth would just be I. Now, suppose I had, say, I to the 37th. What I can do is we could kind of use division and see how many, we could probably use out of the fourth if we want to and see what that does. Because if we can break it down to these here, we know I squared, I cubed, and I to the fourth. Let's see where this takes us. So if we do 4 into 37, be a little bit of division. 4 goes on 37, that's like 9 times. 9 times 4 is 36 with the remainder of 1. So out of the 37th really means the same thing as I to the fourth raised to the ninth power, because that means there's now 36 of those, times then 1 more I. Well, that's just 1 times I, which is going to now be I. So I to the 37th would be the same thing as I.